Elephant toothpaste is a common experiment often performed in secondary education due to its exploding nature, its fast rate of reaction, and colorful appearance. The experiment is thoroughly engaging and demonstrates basic chemistry of reactions and what a catalyst does in a reaction. The name elephant toothpaste was given to the experiment due to the stream of bubbles that pour from the flask or tube in the experiment. Usually the experiment is conducted in a container with a narrow mouth to allow the foam to spurt upwards just like a tube of toothpaste. And due to the sheer mass of foam and hydrogen peroxide it produces, it is said to be fit for an elephant. This experiment is good to teach as it shows multiple concepts of basic science, such as matter, energy, and forces.
Matter is everywhere around us and has mass which takes up space. Matter is composed of atoms and molecules. Elephant toothpaste is a decomposition reaction where hydrogen peroxide is forced to break bonds under the right conditions. In elephant toothpaste, the liquid compound being reacted is hydrogen peroxide, which is relatively stable. The catalyst is generally sodium iodide or potassium iodide. The iodide ion acts as the catalyst as it is not produced or consumed in any way. It only activates and speeds up the reaction. Once the catalyst reacts with the hydrogen peroxide, it becomes water and oxygen, therefore releasing a gas. The oxygen gas is captured in soap bubbles in order to see it more clearly. These soap bubbles are made of two layers of soap molecules which trap a layer of water between them. Soap molecules have one end that repels water, which is hydrophobic, and the other end attracts water, being hydrophilic. The hydrophobic tails of the soap molecules are turned out towards air. Therefore, the heads of the soap molecules are turned towards the water layer. Without these kind of molecules, the bubbles would not hold together and would burst into tiny water droplets. The bubbles which make up the mass of foam are spherical, due to the effects of surface tension. This helps minimize the surface area. The law of conservation of mass states that within a system, the amount of matter will remain constant. So in the case of elephant toothpaste, the atoms change the way they are arranged, but they are still all there. Therefore, the species undergoes chemical change, where different substances are formed. In order for this to occur, the covalent bonds of hydrogen peroxide are broken.
Everything around us has at least one type of energy. The most common is potential energy and kinetic energy. This is also true in the elephant toothpaste experiment, as the reaction is a decomposition reaction. A decomposition reaction is a type of chemical reaction in which a single compound breaks down into two or more elements or new compounds. Before the reaction occurs, the chemicals hold a certain amount of stored energy, or potential energy. This is equal to the amount of bonds currently in the substance and how tightly these bonds are bound together.
Forces are naturally occurring and apply to all things. These include, but are not limited to, gravity, friction, and buoyancy. Gravity, friction, and buoyancy apply to the elephant toothpaste experiment. Gravity is acting against the bubbles, so the force produced by the reaction must be able to overcome the downwards force of gravity. Friction is also applied to the reaction as the foam has to move throughout the reaction vessel and out through the opening, which all would be applying the force of friction in the opposite direction of which the foam is moving. Buoyancy also plays a role in this experiment, as the more buoyant the gases from the reaction are, the faster they'll move up through the air, carrying the foamy bubbles with them.
This representation of the experiment is set up on a website page with a video for visual aid. On the website, it is clear that the directed audience is kids, as the chemicals such as 6% hydrogen peroxide and yeast are used, which are easy to acquire and also safe to use.
First, we've got, this is actually a hair care product. It's 20 volume, it's hydrogen peroxide, but it's a little stronger than what you might find in the drugstore.
The video used to aid the website is great for young audiences as it is simple but also touches on the reason why the experiment works. While explaining how the experiment works, the demonstrator talks about the matter side of the experiment.
Yeast. Dry yeast, believe it or not. This is going to be our catalyst. Hydrogen peroxide is H2O2, so it's like water but with an extra oxygen. We're going to try to get that oxygen to come out. So, 1 tablespoon.
As he states, the hydrogen peroxide will go from an aqueous solution to gas, which will then get trapped in the soap, resulting in the large amount of foam that we see.
And you see it's steamy? Yeah, that's the, it's an exothermic reaction, so it creates heat too. This one,
Concepts about energy are also stated, as we are told the reaction is exothermic. But this is lacking as we are not told the reasons why it is exothermic. This is also another recurring problem with the concept of forces, as it is barely mentioned in the website or the video itself.
Another demonstration important to highlight is this YouTube video, compiled of 4 different representations of elephant toothpaste. Level 1 is aimed at children, using 10% hydrogen peroxide and yeast. This reaction occurs in a flask and is quite slow and controlled, meaning it's safer and easier to view what is happening. Level 2 increases the concentration of the hydrogen peroxide to 20% and also switches the yeast for a stronger catalyst, potassium iodide. This occurs in the same vessel and is significantly faster. Due to it being aimed at an intermediate level, it introduces heat. Level 3 refers to an ultimate level, with the concentration increased again. It shoots foam from the vessel even faster. Level 2 and 3 are good comparisons and point out that an increase in concentration of hydrogen peroxide will increase the amount of foam due to more oxygen being released. This YouTube video provides several methods along with text to identify what is being used. However, they fail to address anything further. This kind of source could lead to misconceptions through a lack of communication of the science in the representations of elephant toothpaste. This would be a great source to inspire teachers in terms of how to set up a demonstration. However, it doesn't provide a child with answers and can allow them to create their own misconceptions. As it does not fully complement a learner's needs, it could be improved with a voiceover explaining what is occurring in terms of the reaction.
As we can see in the representation presented by WizKid Science, there is little to no scientific concepts or explanations presented in this video. This could be due to the level of understanding of the presenter. Talking about the scientific concepts involved and how and when they would apply would have greatly improved this representation and added much more value for the viewer to take away from it. Overall, the experiment elephant toothpaste demonstrates many concepts from the 3 big ideas. Matter can be used in the form of basic chemistry to explain several concepts such as heat, bonds, decomposition, balanced chemical equations, the generation of bubbles, and phase changes. Forces, which demonstrates how friction, gravity, and buoyancy play a role in the real world, and energy, showing us how bonds that store energy are able to be broken in order to give us a release of energy in the form of heat in an exothermic reaction. It is important to consider scientific concepts and how they are represented in educational experiments in order to ensure the best level of understanding for the target audience.